Hello friends, in today's question, consider a body shown in figure consisting of two identical balls, each of mass m, connected by a light rigid rod. If an impulse J is equal to mv is imparted to the body at one of its ends, what would be its angular velocity? So this is a figure of rod having length L, there are two masses m and m, and impulse is imparted at one of its end. So impulse, let us first of all consider what will be the implication of the impulse. Impulse implications. So first will be that impulse is applied to one of its end. So you can say impulse J is applied at one end which creates an angular momentum around center of mass, angular momentum about center of mass of the rod. And the distance of the center of mass from the point where impulse is applied is L by 2. The distance from center of mass to the point where impulse is applied is equal to L by 2. So this is our suppose center of mass. So this distance is our L by 2. And we can say this impulse will result in angular momentum. Therefore, angular momentum due to impulse, which we can also call it as the initial angular momentum, So we can say that L initial will be equal to angular momentum due to impulse, and which will be equal to L by 2 and multiplied by the impulse J. Therefore, we get L initial is equal to L by 2 multiplied by mass into velocity. Now the final angular momentum, So we assume that after the impulse, the rod is going to rotate about center of mass with some angular velocity omega. After impulse, the rod will rotate about its center of mass with some angular velocity. Let us suppose that is given as omega. Therefore, we can say that moment of inertia of the system about center of mass. Moment of inertia of the system about center of mass, we can write this as I. Center of mass is equal to 2m L by 2 whole square. So this comes as m L square by 2. Therefore, the final angular momentum, thus the final angular momentum, let us call that L final, which will be equal to I omega, and we get this as m L square upon 2 multiplied by omega. Now, using the conservation of the momentum, initial angular momentum will be equal to final angular momentum. Conservation of angular momentum, L initial will be equal to L final. So initial was our L by 2 multiplied by mv, and final we have m L square by 2 multiplied by omega. 2 cancel out mass with mass, and this square with this. So therefore, we get that our angular velocity omega is equal to v upon L. So this is the value of angular velocity. This is the value of angular velocity. So from the option available to us, I clearly say that option number A is the correct option. Option A is correct. So this completes the question. Thank you.